Rational number, I think everybody knows, but like for example, 11 over 3 is an example of a rational number. 4 over 7, and I think everybody knows, but we're looking for rational solutions, non-natural number solutions. Okay, something like that. Okay, so those are examples of rational numbers, and the only information we're given is that if you sum r with its reciprocal, you get 773 over 374. Now this is definitely a direct translation problem. We take the rational number, we sum it with its reciprocal, and we just write down exactly what the problem says. This very first part is a common technique. You combine the common denominator by default is r, and so r squared over r gives you the r you see right here. Of course, 1 over r is r. So everything is completely reversible right here. Now once we have it written as a single fraction, we can cross multiply. Here's what we end up with. All right. Now, so we're looking for rational solutions to this equation. Now, it's very well known that it's important to know what the divisors of the constant term are. Now, what I've done here for you is written the prime factorization, which is very easy to determine after you divide it by 2. It's 2 times 11 times 17. Now, there's a result that says there's going to be 8 divisors here because you actually just increment each of these exponents. 2 to the first, 11 to the first, and 17 to the first. If you ink those and multiply them together, you get 8, which includes 1 times 74. But let's write down the ones that so-called non-trivial ones. Let's just pick 2, for example. 2 times 11 times 17 will be a factor pair. So that would be 2 times 187 right here. Right, one possible factor pair. All right, now if we group 2 and 11, that gives us 22 times 17. So you see this is 4 of the 8 divisors, 2 times 187 and 22 times 17. Now the only other grouping that we have to look at would be if we paired off 2 and 17. 2 and 17 and 11. 2 times 17 is 34. So you could also look at 34 times 11. Now, y'all, the reason why we're doing this is I'm just taking on a trial and error approach here. And so if we go through all the factor pairs, we can be certain that we've examined all the possibilities. Okay, so notice I did leave out 1 times 374 because 1's not a rational number. And it wouldn't work out, and you can see that later on. But anyway, these are 6 of the 8 divisors. Okay, call them non-trivial if you want. Okay. Now again, I just adopted a trial and error. You know it has to be in this form, right? And the A's and the B's are going to be chosen from this list. It turns out 22 and 17 fit the bill, and you guys can verify the arithmetic on that. Okay, but the key aspect is you do need 2 minus signs here to preserve this minus sign, and the rest of it's just pure trial and error. Now, another approach would have been to do the discriminant and get, work from there, but that involves a fairly large computation. Now, so these 2 statements right here, this by the zero factor theorem implies that r is equal to 22 over 17. One possibility. And taking reciprocal is what they call idempotent, and the math here reveals that. But well, I don't know if that really helped much, but anyway, 22 over 17 right here, and then also 17 over 22. (17) divided by 22. There we go, folks. So that is the solution. And again, perhaps there's better ways to do some kind of grouping or whatever. I've seen people that just at this stage right here, they try to pair it off into a grouping problem where you split this constant term up. That I think there's just as much trial and error there as there is just writing out all possible divisors. Now, y'all again notice that 1 times 374 would be a possibility, but then you would get like 1r minus 1 or something here, and r equals 1 is not a solution. R equals 1 clearly is not a solution, so there's no point in looking at the 1 times 374 factor pair. But this was the factor pair that ended up getting it done. And again, it took me at least, 10 minutes or so to go through the trial and error, because it's just tedious computations. But anyway, these are the solutions. R equals 22 over 17 and 17 over 22 are the solutions to this original problem. All righty, that's all.